So this will be a slightly different talk than the previous talk. This will be how AI is being used in signal processing research. But there is an angle where we can exploit it for teaching as a tool. So I will present the research work and then I'll give you an example of how maybe it can be used to train people. So thank you to the organizers for inviting me here. Quickly, I'd like to introduce that there is an international conference on signal processing which will happen in Hyderabad 2025 for the first time in India in 50 years. Okay. Since education involves teaching and research, so the goal of this talk would be to present two case studies, how AI can be used in healthcare and AI can be used in navigation. So AI in healthcare topic is basically, it's a research activity jointly between Indian Institute of Science and a hospital in Bangalore, Jayadeva Institute of Cardiovascular Science and Research, and it has been funded by the local University of Health Sciences. So I'd like to look at a specific case of echocardiography. So typically when a patient or even a healthy subject walks into the echocardiogram, or it goes to a cardiologist and they recommend echocardiography. So the examination of the heart using ultrasound is a routine investigation. Even if you are healthy, you can do that, right? Now, most echocardiograms remain unrecorded as there is little demand for secondary analysis. Now, the third point is very important. The analysis of an echocardiogram continues to be subjective. That is, it is dependent upon the operator's experience. So, what I'll explain to you is the following. Now, when the echocardiogram is presented on the machine screen, the sonographer actually has to manually annotate the region of interest. Okay, so they do it manually. Now, a beginner sonographer has less experience than an experienced sonographer. Now, based on this annotation, some parameters are estimated by the instrument. And that tells you, for example, what is the ejection fraction. That is, how well is your heart pumping, right? Now, can I use some tools to help people find out the ejection fraction automatically? That was one question which doctors asked. But the same tool can be also used for training a sonographer. Suppose a sonographer gives a certain annotation and then the algorithm gives and the automatic tool gives you a different one, the sonographer can be trained. So the goal was to see whether we can first build an automation tool and then use it for training an expert sonographer. Training a sonographer to become an expert. Okay? So how do we do that, right? So we can do that by taking an experienced sonographer and annotating the echocardiogram such that we get the ground truth or the expert. Now, I am a beginner and I want to become an expert, but the expert, I can't have training under an expert always. But if a tool can help me scale the process of training a sonographer to become an expert, then that will be very valuable, right? So now comes the technology. Can I use AI or deep learning techniques to create this tool? Okay, so that is the research part of it. Now we all know that for a AI tool, we need to do a lot of training. That means we need to generate a lot of data. Give it to the algorithm, it will give you what you want, if you tell them what it is. So that is the idea, to do automatic identification in view of the cardiac structures and measuring the volumes of the ventricles and so on and so forth. So typically, no need to go into great detail, an echocardiography protocol has that the heart is a three-dimensional structure, right? And also, it is not that it is pumping in one dimension or two dimensions. It also has a twisting, okay? It has a twisting. So when you want to calculate how well your heart is functioning, you need to compute volumes, right? Volume is a three-dimensional parameter, right? You need to compute volumes. So if you want to compute volumes, one single two-dimension view will not be able to give you accurate estimate. So typically, they are supposed to do two views to find the volumes of the chambers. But usually in our echocardiogram, we all do it in only one section. But we are supposed to do it in two because it takes more time, they skip. Okay? So if you look at it, this is an example of how the experiment was conducted. You go to a hospital. So we went to the hospital. This Jayadeva hospital does 500 echocardiograms every day. Okay? So they do it every day. So about 5,000 echocardiograms we collected from subjects who walk in. They are like an outpatient, right? An average age was 44 years and so on and so forth. Now they go into this, we collect the echocardiograms, and then we are supposed to find the ejection fraction as a tool. So if you look at this slide, you will see that you need to, the top is basically one view of your heart, of somebody's heart. Now the bottom view is what the person is annotating. Okay? The person is annotating. The sonographer says, this is the region of interest. This is one of the chambers which I am interested in. That is the blue shaded part. Now, the blue shaded part, and then the middle one is telling you that it computes the area. Many of you would have learned what is called Simpson's rule of integration. That is what is done in that instrument. But you need to draw the region of interest. Okay? So now what happens is, if you do that, can I automate this? Right? That was the idea. So if experts draw this and a beginner draws it, the calculation is different. So here you are able to see that if I am able to do an automatic segmentation of using deep neural networks to find where the chamber is. Now this slide or this video is actually the output of an AI tool which has got the area and the volume correctly. Okay? So now how can I use it for training? So this is a tool which is generating the data or the region of interest. And now we can use this to train people by comparing with an expert. So the AI algorithm has been trained on experts who have given the annotation. So the AI is closer to the expert than a beginner. But the beginner can use it to learn how to become an expert. So that is the next step. These are all preliminary results. So this is trying to automate and finding the characteristics of the heart, the function of the heart. So this is just an example. As I said, we can use AI. First you build the tool and then you use it for training and learning and educating people. So people can then learn. This is one case study. The other case study is what we are trying to do is more research oriented. We're trying to look at some difficult problems. Maybe sometimes you may say it is irrelevant in India, but we wanted to understand what is navigation. Navigation means going from one place to the other. How does AI help us in doing some automatic stuff? So this is again a joint research activity between IISc and Wipro. So this is slightly more research oriented. So we have built what is called a national data set and data platform called the Wipro IAC Research Innovation Network. So quickly, the navigation, right? We want to see how AI can be used in navigation. So navigation is basically moving from one location to another location in a chosen environment. That is what we do. If you want to walk across this region, I have to first understand the scene. I do a scene analysis. I try to do detection of objects in the scene. And then I create a navigation algorithm to avoid collision and I walk. Right? This is how navigation happens. Autonomous navigation means that there is no human in the loop. You let the machine try to do it. So there was a problem which was posed by a company called Volvo. Basically said they wanted to look at, is it possible to use AI in navigation of large trucks in a mine? Okay, this is a coal mine. So this coal mine is in near Bhadrachalam, that is Ramagundam coal mine in Telangana, near Hyderabad. So the coal mine has lot of. So what happens in a coal mine is the following. Every day for 2 hours the coal mine is shut because they do explosion, because they are going deeper and deeper. So they explode, they detonate, and then trucks come, excavate whatever is detonated and bring it to some dumping place where it is then loaded onto other trucks and it is sent to the complete ore is sent. So as you can imagine, there are no paved nice roads with markers and so on and so forth. They're all muddy lanes, as you can see. Now what has happened is the operator in the mine, the operator has found that these people who are driving on these muddy lanes are getting tired because they don't have the roads are quite muddy and there are no proper signs, etc. And a lot of accidents are happening. So they wanted to know, is it possible for you to detect a truck in front of us in a muddy environment? But first you do it on a regular road and then we will transport it. That is what Volvo wanted. But they didn't want to put a radar system. They wanted to use only one webcam and say use your deep learning AI tech tools to find out the distance between two trucks. That was the problem which was posed. Basically, Project Envelope is environment perception and vehicle localization using peripheral sensors. So what they said was that don't use any radar, use only a camera and find out where the collision happens. The truck braking distance is 25 meters. That means after you apply the brake, the truck is so heavy, it will stop only after 25 meters after applying the brake. It will not stop instantaneously, right? So you need to know the distance of the truck in front of me, which is less than 25 meters. Then we are in a safe one. So the goal was to find whether we can use video processing to find the distance of a truck in front of you. So in any AI-based research or AI-based algorithm development, we require a lot of data. Now we will not have data about these videos of trucks, so we have to collect it. So therefore, the first step is data platform you build, then you collect, and then you manually label them. Once you label them, then you can run your algorithms to automatically detect. Okay? So the hardware was restricted, that they just wanted a simple webcam because they didn't want to make it too complicated. So just a Logitech webcam with a small GPU card, and then you have a GPS receiver, and we had a trial run of trucks, 2 trucks moving in a particular controlled environment, not on muddy roads, but just in controlled, because we wanted to see what it was. And then we took data from parking lots and also. This is the Volvo factory near Bangalore, Hoskote. So the information basically was to collect data at this factory. So every Volvo truck and every Volvo car which is running in this country goes through a test at this factory. What you are seeing is a test track. So the test track has regular road, road with potholes, road with waterlogged roads, etc. So every vehicle goes through this test and then it comes out. So we used a lot of videos and then used neural networks, basically calling, there is a neural network called AlexNet, etc. and tried different networks and found that a certain neural network gives you good accuracy to determine the truck in front of you. So I'll show you a video. So this is running at twice the speed. It's not, so just to show you. So you can see on the top, you will see that on the bottom is the distance in meters, and on the top is basically a label which says safe or danger. So if you see the label danger, that means it is less than the braking distance. If it is more than that. So what is the idea? The idea is that we all know that if an object is closer to you, it looks bigger. If the object is farther to you, it looks smaller, right? So that is the concept in the algorithm getting trained. So you will see here that this is the test track which I showed you. So the vehicle, when it goes, when you are closer to the vehicle in front of you, so this is the experiment we conducted, you will be able to do it. So this is just a power of AI which can be used to determine whatever. The second problem posed by Wipro in the navigation space is our regular traffic issue, right? Can we drive here autonomously? Now that is a very challenging problem because you see autonomous cars in other countries. Can we drive here? Obviously you will say that it is almost impossible for us to find autonomous. But then Wipro wanted to build a solution, so we said, okay, let's try it out. Okay. So in any algorithm development, as I said, you need to first have a data platform. You collect a lot of data. Then you annotate data. Somebody has to say this is this, this is this, this is this in the object. And then you build neural networks for segmentation and identification and trajectories. So if you look at data sets, there are many data sets which are open and source or open data sets, but they're all belonging to situations which are not Indian. Okay? They're all very nice structured data. So the goal was to see whether we can build an Indian data set. So we actually looked at building a sensor platform, and using that sensor platform, we drive that platform in regular traffic of Bangalore, collect data, do annotation, and then see whether we can do some prediction of transport. So the architecture is you have an in-vehicle sensor platform, you have a data collection system sitting in the car, and then you want to build the algorithm. So this is the picture of the sensor platform which is mounted on a car, and then it has what is called a LiDAR, which is light detection and ranging. Like a radar, it is LiDAR. It gives you three-dimensional point clouds, and then you have cameras in front, you collect the data. So typically you will see these are pictures of when the car is going through, this is on IAC campus. So this is the LiDAR image, and this is these are the camera images. Okay. So if you look at, just to quickly give you a sense of what is happening, I don't know why it is not working, but you will see that there is okay, let me see if it works. So you can see that as the cyclist is moving, the two cameras are giving you a picture and the LiDAR is giving you the images. So this is the input to your algorithms to find out where things are, right? So that's basically what it is. So I'll just just run it through this. So if a cyclist, a motorcycle, you can see on the right side is the LiDAR image, on the left side is the camera image. Now the navigation algorithm is supposed to find where each of these are and then find the stuff. Okay. Similarly, one more in Bangalore city. So in the dark, you can see on the left side is in the evening or in the night, but the LiDAR is able to capture some three-dimensional portion. So this kind of data is collected. About 650 kilometers of data we have collected, different kinds of data, heavy traffic, low traffic, medium traffic, and so on and so forth. And then you create this database from which we are supposed to annotate and look at the data, right? Now what is the goal? So you can see here, left side is the raw image, right side is the annotation. Now this annotation is happened manually. Students have done that, okay? So here it will tell you somebody sitting on a scooter, person, helmet, scooter, car, like that, okay? This annotation. So you can look at different kinds of annotation. All this is then given to so we build a annotation studio. So somebody will manually go look at the LiDAR image and create a box or a volume and say this is a car, this is a bus, and so on and so forth. So I will not go through all detail about this. So just to show you that there is a box which is created manually, and that is what happens. So I'll just skip this in interest of time. Now there was an additional data set which we went to the Bangalore Traffic Police, and we want to understand how we can identify vehicles on Indian roads. So they gave us some old data because they said we don't want to give recent data. So they gave some quite old data, and it is from a traffic junction. Okay. So traffic junction, they gave about 100 GB worth of data they gave us, and we wanted to see whether we can identify bus, tricycle, and all that. Okay? That was the goal. So the goal was to test whether AI can detect vehicles on Indian roads, right? Autos, buses, motorcycles, and so on and so forth. So I'll not go into great detail about different algorithms because that is not what is important. But you can see there are some results where you can see each frame, you are able to identify objects in that frame of the video. But you will also identify on the left side, if you see, the lorry was not identified by the algorithm because it did not see many such lorries. This bus also is not identified, right? Some of the other items or objects have been identified. An auto, a person on a motorcycle, and so on and so forth. But a person walking was not identified, correct? This car was identified, but other things are not identified. So these are, AI does not give you everything perfectly. So I will not go into these technical details. These are all AI. So then what I will show you is that this is a data collected on a college campus, RV College of Engineering. They were our partners. Now you will see that when the vehicle is moving in the campus, it is able to detect the, so let me show you again. Yeah, so I will, you see, okay, sorry. Yeah, let it play. Yeah, what I wanted to show you here is, in the campus, you see motorbikes parked on the left side, you see a car on the right side, you see some persons walking. But what you see is, it identified the pavement, a part of the pavement as a bench, right? So the algorithm made a mistake, right? It is actually a pavement, but actually identified as a bench. So that's what, so your AI algorithms, you have to be careful whether they work always, right? So I think I've missed this. Let me go to, okay, so when you keep going, slowly you will see that it is able to identify persons, but it also makes errors in looking at the pavement as a bench. And also sometimes it may look at a big bush and call it like a car. Okay? So it can make some errors. So this is, but there is enough power in these neural networks where you can detect Indian traffic items, which we can maybe see how to use it for navigation. So this is just as an example I wanted to give. Similarly, if you take, this is running at twice the videos, twice the speed. So traffic is bad in Bangalore, but it is not like this. So, but you can see that the algorithm is able to detect buses, trucks, lorries, autos, people walking, and so on and so forth in the video, right? So you can use this technology to identify vehicles in Indian scenario and then build what you want to do. Okay? So this is another, so this is one more example I want to give you, that AI is so data driven that you will see some object coming in now and the algorithm cannot detect that. So you can see that now when it comes. That is a car. It is not able to detect this big object, right? See this one, it could not detect because it never saw. We never trained it on a, a horse-driven jhatka or tonga, whatever you call it. So again, the idea of the using AI is that you have to be careful in what you use data to train and what do you expect. So not everything which AI gives you is right. Okay, you should be careful in interpreting data coming out of an AI platform because you don't know on what data it has been trained. So from an Indian context point of view, it is necessary for us to collect data sets, use data sets from the Indian context, and then train your algorithms to use the power of AI for your whatever tools you want to build. Okay? So after building, identifying objects, these are different tools called social GAN, etc. I'm not going to go into it because it's not a technical talk. But next thing is that you want to predict the vehicle's movement, right? After you identify the object, you want to know where it is going so that then I can build a navigation algorithm. So here you can see that the blue and the green, these are important for us. The green is the ground truth and the blue is the algorithm of AI, right? In some cases it is aligned, in some cases it is very close, some cases it is a slight deviation. And there are other techniques we call model-driven techniques which are not performing as well as they are expected to do. So AI has, or deep neural networks have some power. Okay? This is just as an example. So I want to end now to acknowledge all my colleagues and students and thank you. Stay safe and healthy. If you have any questions, I'll be happy to.
Thank you, Dr. KVS Hari, for your fascinating keynote address on AI in signal processing research. Your deep dive into the intersections of signal processing and AI, spanning MIMO systems, radar, navigation, assistive technologies, and neuroscience, has truly enriched our understanding of how these advancements are shaping the future of technology and research. Your expertise, backed by significant contributions to the field, inspires us to push the boundaries of innovation and interdisciplinary applications. We would now like to open the floor for a brief Q&A session. Participants, if you have any questions for Dr. Hari, please raise your hands. Let's make the most of this opportunity to interact with the stalwart in the field.
Hari sir. Sir, my question is regarding navigation softwares. How you extrapolate the mine drug relation with that of Chandrayaan? In Chandrayaan, they arrived at the lunar south by the navigation software itself, which cleared the boulders, the craters there. So everything is done by the detection algorithms. So my question is another aspect of autonomous car. The Tesla, the autonomous car maker says, in India and Brazil, they can't train their autonomous car because we are massively traffic violators. And the terrain is undulated. So it is very tough for the algorithms to gather data. Another part of sonography. Sir, if cardiosonography is done vigorously, massively, the job of a lot of sonographers will be out. What is your take on it? The sonographer job is threatened because of the fact that it is done by algorithms. Algorithms mimicking the cardiac injecting power, the blood flow power, etc. is being mimicked. So the sonographer job is already a threatened one. These are the questions, sir.
Okay, I'll take the second question first. It is not about sonographer's job is going to be out of action. Any instrument or anything, it is not true that they will lose their jobs. It is that they will become better. Okay? These tools can be used so that your efficiency improves. You can do better things. You can address more people. More patients can be, the scans can be done because you are taking the help or the aid of these tools. So instead of you waiting for an echocardiogram for 2 hours, you maybe only have to wait for 10 minutes because the sonographer is able to do things quicker. It will not replace. Remember that AI will never replace a human being. AI is only an aid. It aids the doctor, it aids the sonographer, it aids a mechanic, it aids a designer. So AI is not going to replace everything because AI is only as good as the data it is trained on. Okay? Unless you have the full amount of data, it will not match that. Okay? So just think of it like this. Why do we need to use such tools? So think of it, in a hospital, there is a doctor who is experienced, who has, let's say, seen maybe 1,000 patients in many years of experience. Now a young doctor comes in, right? They would see only a few. But if I take the information from, let's say, 1,000 doctors, put it in this AI tool, it is like having an expert who has seen several thousand data points, right? So a young doctor can learn from this tool quicker than spending, shadowing, etc. So this is the goal, but it should be based on correct data. You give wrong data, it will give you a wrong result.
So a budding sonographer is gained by the expertise given by algorithms.
Yes.
Deep learned or ML, machine learned.
Yeah.
So he is made an expert.
Yes.
There is a point you are
that this can be used as a training tool. So that you can make the sonographer be better and better.
Sir, regarding the autonomous car, the ethics of autonomous, if somebody is hit by an autonomous car.
I didn't understand the first question. Yeah.
The truck.
Yes.
Mine scenario.
Yeah.
Extrapolate it to Chandrayaan. During Chandrayaan, our space capsule landed at the lunar south. Yes. Because of the navigation software, deciphering out the craters, boulders everywhere. So how you connect this, the navigation software of the truck driver and the mine system to that space?
That it is tough because we need to get data of that terrain before we train. Excellent. So it will be very difficult to train for that application. It will not be easy.
Thank you, sir. Thank you.
Thank you, Dr. Hari, for addressing these questions with such clarity and depth. Your insights have truly left a lasting impression on all of us. To express our gratitude, we would now like to present you with a token of appreciation. I invite Dr. Rajesh MV, Principal, College of Engineering, Pune, to kindly come forward and present the token of gratitude to Dr. KVS Hari. Once again, Thank you, Dr. Hari, for sharing your invaluable expertise and being part of this conclave. Let's all show our appreciation with a big round of applause.